Hi, everybody, it's Mrs. Bianchi. We are going to make sure we all understand the difference between perimeter, area, and volume. And we're going to fill in this chart that's provided on page 2 of your workbook. All right, so let's look at a closer look at perimeter first. What I have down here is I have a straight line, and a straight line can be in different units. It could be an inch long, it could be a centimeter long, it could be a yard long, it could be a mile long, it could be any measure of length. So if it's not mentioned what that length is, then you would just use the word unit. Now, if I were to figure out the perimeter of this rectangle, I'm basically counting how many of these do I need to go around the entire thing. So if I just go on this side, I have 1, 2, 3 going that way, which means the opposite side would also be 1, 2, 3. And going the other way, if we count going down, let me grab my pen, it would be 1, 2, 3 going that way, which means this would be 1, 2, 3 going that way. So when we're talking about perimeter, we're talking about the distance around the entire figure. So if this is 3, and this is 3, and this is 3, and this is 3, the perimeter of this particular rectangle, actually it's a square as it turns out, would be 3 plus 3 plus 3 plus 3, or in this case 3 times 4, which would be 12. Now what about area? How is area different than perimeter? Let me erase everything I have here. And I do want to drag my little red line here down here below so that you can see that with area, we're not talking about a straight line. We're talking about tiles. I like to think of them as tiles. And you're really asking yourself, how many tiles can you fit over the surface of something? Now, these tiles can also differ in dimension. It could be 1 square centimeter, it could be 1 square inch, it could be 1 square meter. So how do we figure out what we're talking about here? So let's say that this is a square centimeter, then we're talking about the side of each of these being 1 centimeter by 1 centimeter. So we're talking about how many of these can we fit over the surface of it. So if we just simply count 1, 2, 3, 4, 5 going that way, and going down, we have 1, 2, 3. So essentially, we have 5 times 3, which would be 15. Now, could we just count them one at a time? Sure, we could. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So to find the area, you would take whatever the length is, which in this case we said was 1, 2, 3, 4, 5, and multiply it by the width, which we said was 3, and 5 times 3 would give you 15 square, in this case centimeters, I think is what we said. Volume, how is that different from the other two? So I have an image or a model of a cubic centimeter, in this case, cubic centimeter. Cubic means you have length, width, and height to it, 3 dimensions. So if we were to try to figure out how many of these we need to make up this figure, then we need to say to ourselves, well, how many do we need for this front piece? So do you see how if this is 1 going this way and this is 2 going this way, and then we have the ones on the bottom? So really, what are we doing? We know that going this way, if we just count, that's 1, 2 units going this way. We're 1, 2 units going this way. And how many are we going this way, going back? We are 1, 2, 3 going back. So to find the volume of a rectangular prism, you would need to multiply length times width times height, which in this case, the length is 3, the width is 2, and the height is 2. So if we multiply these 3 numbers together, 3 times 2 would give us 6, and 6 times 2 would be 12. So we have 12 cubic centimeters in the image above. All right, now let's talk about the chart that you're going to have to fill in. So for the chart that you have to fill in, they want to know what the measurement is. So perimeter, we mentioned how that's the distance going around the figure or the shape. For area, that's the amount of space inside a 2D shape, or I like to think of it as how many tiles you need to cover the surface of it. And for volume, it's the amount of space inside a 3D shape. So in other words, how many cubes you need to create the three-dimensional figure, or we would call that a polyhedron. How to find the measurement for the shape shown? Well, how did we